Hey guys, Mr. Ford here. This is going to be a real quick video on polygons. First, we're going to define what a polygon is, and then we're going to be able to, using this worksheet, we'll determine whether or not polygons are what we consider similar, right? So a polygon is nothing more than a closed figure with three or more sides, right? So polygons, I'm going to say, are closed figures with three or more sides. So we have actual mathematical terms, scientific terms for each polygonal shape based on the number of sides they have. And at some point in time, I may introduce all of them and go over that. But for now, it's not really that important. Just know that it's a closed figure with three or more sides. And this is the key word, sides, right? And I'm going to show you why. And this first, number one, so what we're doing here is determine whether or not these are actual polygons. If the polygon is a polygon, name it and tell whether it's a regular polygon or not, right? And I'm going to talk about what regular means as well. So the first one, number one, this is an oval, right? It's an oval similar to a circle. It's got some ovality, which means it's not quite centered. It's not quite perfect. But this is not a polygon, right? Because there's no clearly defined sides. Now, if you had something very similar to this, but with clearly defined sides, then yes, that would be a polygon. But this is not a polygon, right? So for number one, it's not. Number two, this is a polygon. It's clearly defined sides. The thing is, it's not a regular polygon. It's not regular because for it to be regular, all the side lengths would need to be the same and all the interior angles would need to be the same. So this is actually, it's a polygon, number two, but it's not a regular polygon. And this, and all you do is count the sides. So we'd have 1, 2, 3, 4, 5. 5 sides. And a 5-sided polygon is a pentagon. All right, number three, you notice how there's this gap here? That opening tells me it's not a polygon. Number four, this is a polygon. All those side lengths, it's closed in. Now, of course, you would count all the sides that it has, and I'm just going to go through them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is a polygon, and I'm sure there's a word. I don't remember the one for 16, the actual scientific word, but just to use layman's terms, easy terms, you could just say it's a 16-sided polygon. Now, this one, you would look at it and say, oh man, it looks like a regular polygon, but it's not a regular polygon because the interior angles are not all the same, okay? So this would not be a regular polygon, but it is a 16-sided. Number five, see this little extension here at the bottom? It looks like a flagpole. That's not a polygon, right? Number six, it's not a closed-in figure, so it's not a polygon. Number seven, it is a polygon. It's closed in, and you can count it's 1, 2, 3, 4, 5 sides, so it is also a pentagon, but it's not a regular pentagon. In fact, the next one, number 8, is a regular pentagon. A regular polygon, but it's actually a hexagon. It's a 6-sided. So number 8 is And this one is a regular hexagon. And the reason you can tell it's regular, it has, see these hash marks? Let me zoom in a little bit. These hash marks mean all those side lengths are the same, right? And since all those side lengths are the same and all those interior angles appear to be the same, then that would be what we call a regular hexagon. Number 9, somewhat easy to see this is not a polygon. 10, same thing with this little extra portion here and the fact that it makes somewhat like an arrow. That's not a polygon. Number 11, yes, this is a polygon. What type is it? Well, it's a 3-sided polygon. So a 3-sided polygon is also known as a trigon, right? But we often refer to it, instead of as a trigon, as a triangle, right? The actual scientific word is trigon. We just say triangle because it's something we study in mathematics, and it's a common term, triangle, right? 3 angles. Well, trigon is 3 sides, right? Number 12, this is a regular polygon, right? You can see it's got the 4 sides that are same length, and all these are right angles, right? It doesn't have to indicate it for this, just the fact that the side lengths are the same and those angles appear to be 90 degrees. This is a regular rhombus, right? A regular rhombus, we often refer to it as a square. Regular rhombus is a square. And a rhombus is going to be a 4-sided polygon, a quadrilateral, where all 4 side lengths are the same. This is also a parallelogram, right? And let me write that word out. Parallelogram. And what this word indicates is that opposite sides are parallel. So like say this side and this side are parallel, and this side and this side are parallel, right? So parallelogram. Number 13, this is also a polygon, yes. And it's a 1, 2, 3, 4, 5, 6, 7, 8-sided polygon. An 8-sided is also known as an octagon. Octagon, right? 8-sided. Now, it's not a regular polygon because it's got a funny shape. It looks like a T. But it is a polygon. It's an 8-sided octagon. Number 14, not a polygon. 15 is, of course, it's not a regular shape. It looks like a pair of shorts, actually, running shorts, but it's not a regular polygon, but it is a polygon. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sides. Did I count that correct? Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9-sided polygon. It's not a regular. Yes, it is a polygon, but this is what we would call a nonagon. Nonagon, right? 9-sided. Now, for number 16, this is draw an 8-sided polygon. What is its name? A regular 8-sided polygon is known as an octagon, and I'm not going to embarrass myself by trying to draw that by hand, but you get the idea, right? It's basically you have 2 at the top, 2 on the sides, and then each one connects like that, right? That would be an 8-sided polygon. It's an octagon. Okay. And then a decagon, I'm not going to try to draw that either, but this deca, D-E-C-A, right, is also the same root word as deci, which is a 10-sided polygon. Now this one is saying, it doesn't say draw a regular decagon, so I mean you could really just put some sides together. And you would have something. I'm not even an artist. I'm not going to try to pretend to be. That's just something I'm not really into. I like to draw, but I cannot draw well. All right. So real quick, the last thing I want to do is go over similar polygons, right? And similar polygons, just as a general statement, easiest way to remember it, have the same shape, but not necessarily the same size. Right? So if polygons are similar, they'll have the same shape, meaning all their angle measures will be the same, and their side lengths will be proportionate, right? Same shape, but not the same size. So that means angle measures are the same. And I'm going to use this word, corresponding side lengths. Oh, I'm running out of space here. Side lengths are proportional. All right. Side lengths are proportional, meaning, let's look at number one. They appear to be the same, looking at the pictures, but you cannot go off the pictures. You actually have to look at the side lengths. So this is 2 inches, and the corresponding side length on the other rectangle is 4 inches. And then this side length is 5 inches, and the corresponding side length here is 10 inches. So if I were to set up a ratio, I could set it up per unit, like per rectangle. I could say 2/5 is equal to, and then corresponding lengths would be 4/10. If this is a true statement, then yes, they are similar. And 2/5 is equal to 4/10, because if you were to reduce 4/10 by 2, you would end up with 2/5. And 2/5 is equal to 2/5. So yes, they are similar. Now, you could also set up your ratio. Instead of doing it per rectangle, you could say corresponding side by corresponding side. So that would be 2/4 is equal to 5/10. Well, is that true? Sure it is, because if I simplified both of these, if I divided both sides by 2, then I would have 1/2, right? So 2/4 is the same thing as 1/2, and then 5/10, if I divided both sides by 5, I'd have 1/2. So yes, 1/2 is similar to 1/2, right? It's equal to 1/2, so that means they would be similar, right? So that's 2 different ways you could set up your ratios. Just be really mindful of how you set up your ratios. If you were to try to set it up with different side lengths over each other, say for instance 4/5, why is it doing that? Say if you did 4/5 is equal to 10/2, that would not work out, right? You would see that it's not the same, it's not equal, so that wouldn't work out. And you'd be confused because you would think, oh, they look like they're the same, but they're not, right? You have to set up your ratios accordingly. They have to be in the right order. Now, I'm going to do one more with this, and I'm going to use number 2. So notice right away, side length of 10, 10. Looks like it could be the same, but then the shape is a lot different. Now, you can't go off the illustration. I told you that once before. But if you see this corresponding side to this corresponding side, and you already know that this is 10 foot, this is 10 foot, but this is 7 foot and 3 foot, you know that 7 foot is not equal. So that's not going to be proportionate. Now, you could set up your proportion if you want to. You could say 10 over 7 is equal to 10 over 3. Well, that's not a true statement. We know it's not. So if I put a not equal, then I know they are not similar. All right, so the other examples pretty much go through the same thing. If you looked at example number 3, these shapes appear to be the same, but if you notice, this is a 20 by 20, which means it's a square. This is a 32 by 24, which means it's not a square. So a square is only going to be similar with another square, right? This one may appear to be, but it's not going to be a square. So this is not similar. All right. And then the last example on here, it does get into decimals, but if you set up your proportions, you know, for instance, 2 over 2.8 is equal to corresponding sides, 5 over 7. Well, if you were to multiply, do some cross multiplication, right, just to save time, cross multiply, 2 times 7 equals 2.8 times 5. Well, 2 times 7 is 14. 2.8 times 5 is also 14. So yes, 14 equals 14. So yes, they are proportionate, and that means they are similar, okay? Now, you can set up the ratio as long as you have corresponding sides or over each other, that's fine. I just figured this is the easiest way to do it, and I don't want to have this video go on for too long because I want you to continue watching my videos and, you know, getting that extra help in the enrichment you need. So that's going to be it for this video. As always, I love you guys, and don't forget, stay golden, my nuggets.